So in this video, we're going to talk a bit about arrays in C. Arrays allow us to store a set of values that are of the same type, and that's generally what we're going to be using arrays for throughout our working with C. Now, you're going to see that there are a variety of different ways of working with arrays in C. This is just going to be one of the methods that's sort of the most straightforward method, and then we'll talk a bit more about the ideas of pointers and how they can fit into the idea of arrays as well. So to declare an array in C, we do the same sort of variable declaration as we've been doing with normal variables like integers. And what we do is we give it a name, and then we give it a size. So for instance, if I wanted an array that had 5 elements in it, I would just put 5 in these square brackets here. And then what we could do is we can initialize it using these little brace brackets here. So I can provide values for each of the elements, for instance. And then if I wanted to get a particular element, I would reference it by its index. So for instance, if I get A at 0, that would give me the first value inside of my array. So if we take a look at this example here, when I run this, I should get the first value in the array, which is 1 in this case. And then of course, as I continue to increment this index, I'll continue to get the next values inside of the array. So this would be 2, and then so on and so forth like that. We could get 3, 4, 5, and so on. Now, there are a few different things that we can actually do with our various initializations. So for instance, we can initialize less values than the size of the array. And what will happen is the remaining values will just get set to 0. So if I go to, say, index 3, which isn't currently initialized, when I do this, I'll get a value of 0 there. So you see that it just sets it to 0 rather than initializing it. Or it'll set it to the equivalent of 0 for that data type. It will just give it like that initial value, right? And we could explicitly do this for every element if I just put in 0 like this. Here we declare just one element to be 0, and then the rest of them get initialized to 0 as well. So this just initializes everything to the default value. So you can provide the same amount of values as the length of the array. So like this, there's 5 values, one for each slot in the array. You can provide less values, in which case the rest will be initialized to the default value, in this case 0. Or you can provide, well, either you provide the right amount or you provide less. You can't provide more values is what I really wanted to get at there. So you can't provide more values than what are specified here, but you can provide less values if you want. Now, one other thing that we might discuss is the idea of how we manage these constant values. You'll know in a lot of programming languages, we would use constant variables to represent things like fixed sizes like this. In C, we could do something similar using a macro called define. What this does is it allows us to define a variable, which I'll call n in this case, and we could set it equal to a value, like 5. And then what I could do is I could come here and set this equal to n. Basically, all this does is it defines a constant value. It sets it equal to this value here, 5, and then I can use this value to represent the size of this array in all cases. And you'll see that that does generally work. So this is a way that you can actually represent the various sizes and constants in C is using this define. It's called a macro in C, and it's something that's handled by the preprocessor rather than the actual compiler itself. So those are just some things to keep in mind. Now, one important thing about arrays is when we talk about accessing via subscript, one thing you may see if you've worked with higher level languages like Java and Python is if you index outside of the array, it gives you an index out of bounds exception or something of the sort. In C, that's not the case. If I index outside of the array, let's see what happens. You'll see that I get the value 1, which is kind of weird, right? There is no index 8, yet I get a value for it. And that's because C actually doesn't do any checks on the bounds of an array. And we'll generally see how that type of idea will work based on the fact of what C is really doing. It's basically storing a pointer to the front of the list, and then it just increments it until it reaches the desired index. And as you can see, based on this result here, if I put too big of a value in, it will just read arbitrary data. Whatever data happens to be there, it will read it and represent that as a result. And this represents a major problem. So you really want to make sure that this is not possible to do in your application at all. The reason being is because if somebody who is malicious manages to input an index that is bigger than the size of the array, they can read random bits of memory. And who knows what's in that random bits of memory, right? There could be sensitive data in there. There could be program-related data in there. And if they're able to write past the bounds of the array, they can actually write their own code into your program and cause it to execute that code. So this is a potential security risk. And I want to bring this up just so that you're aware of it. This is possible to do. You want to make sure that it isn't done by always checking the actual bounds of the array yourself before allowing the indexing to occur. And in that type of idea, we should say, oh, well, how do we actually check the bounds of an array? So we can get the length of an array in a rather interesting style of method. So what we do is we take a look at the size of the array itself. What this method does is it tells us the size in memory of that array, and then we divide that by the size of a single element inside of the array. So what we're doing is we're taking the total size divided by the size of a single element, and what that will do is it will tell us how many individual elements there are, right? So that's the math behind that. And you'll see that when we do this, we actually will get the length of our array. Oh, in this case, I get a little error here that says this is a long unsigned int rather than an int. So we can change the actual format of this. Just to note, a long int just is a bigger sized integer, right? So integer has a particular bound in terms of its size. It's some number like 2 billion, something like that, I'm pretty sure. And then the long int is going to be much bigger than that. So it's just saying that since the size of something could be potentially large, it uses this long integer format. So we can use LD to represent that instead of D in the print. So let's run that. And as you can see, I get the value 5, which is indeed the length of my array. So using this type of idea, we could do things like looping through that array, or we can, check to make sure that an index is within an array before we actually try to access an index itself. So this gives you a general overview and idea of the way that arrays work in C. Again, main things to keep in mind is the ways that we calculate the length of the array and the fact that we can index outside of the array. So we need to be very careful about when we access and write data for arrays themselves. So thank you so much for watching this video, and I'll see you in the next one.